Thanks, Victoria. Hi, everyone, and thanks for coming. My name is Sarah Sperry. I'm an assistant professor in the Department of Psychiatry here at Michigan Medicine, and I'm an associate director of the Heinz C. Prechter Bipolar Research Program. And a lot of my research uses different smartphone and wearable technology to help understand risk and think about personalized intervention in bipolar disorder. I've been using EMA, ecological momentary assessment, in my research for over 10 years. And I think a lot about how to utilize this data in the best way and also how to make sure that we can trust the data we use. It's a niche, but kind of up and coming, or I guess at this point, it's really made it to the forefront of behavioral health and health research. But a lot of people propose these projects and then get, this massive amount of data and don't quite know what to start with first. So my first talk was really, how do you design an EMA study? What types of things do you think about? And today we're going to talk about, okay, now I have my data. How do I think about whether I can trust this data? How do I pre-process it to be usable for the types of analyses I might want to run? And how do I run some quality control on that data? Goal is that all of what I talk about today, it has our code associated with it that will be made available. Whether that's on the EFDC GitHub or my GitHub, we're figuring out, but essentially we'll send that out to the Digit MI community once that's finalized. So am I good to go ahead and get started? All right. So for those who weren't at the first talk, we're going to just start with a very brief, what is EMA? And then I'm going to couch today's talk in a study example, one of my studies that uses EMA. And then we're going to go through my recommended pre-processing steps that get you to a place where you're ready to analyze the data. And there's 5 steps I'm going to go over really thoroughly and try not to bog down in too much details. So for those who don't know, what is EMA? EMA is a method that typically uses smartphones or other wearable devices to collect data in real-world environments as individuals go about their normal life. So it's going outside of the lab to try to understand people's emotions, behavior, cognition, sleep in the real world as they're, experiencing stressors or life circumstances or normal days or work versus home. So it allows for the really dynamic capture of data. It tends to focus on individuals' current states, and it can be really, really customized to whatever type of research you're doing. I do psychological research, so I do think a lot about emotion, behavior, and cognition, but it can be used to measure all sorts of different things, health behaviors, perceptions, you name it. You can really create an EMA survey to assess it. One of the key parts of EMA, which makes the data more cumbersome, is that there's multiple repeated assessments over time. Depending on how long your study is and how often you're delivering these surveys, you could have anywhere from 100 to 1,000 assessments per individual. So the study that I'm going to focus on today is my study called the Emotion-Based Impulsivity in Bipolar Disorder Study, or EBI. And this study is recruiting individuals who either have no psychiatric diagnosis or healthy controls. Those with subclinical bipolar disorder, what this means is that they have symptoms of bipolar disorder but aren't meeting full diagnostic criteria based on the SCID. And then those with a full-blown bipolar disorder, either bipolar 1 or 2 disorder. And this study is part from my Eisenberg Scholar Award funded by the Eisenberg Family Depression Center and also my K23 from NIMH. When participants enroll into the study, they complete 4 EMA surveys per day for 28 days. Those surveys are set sent at random times between 10 a.m. and noon, 1 p.m. and 3 p.m., 4 p.m. and 6 p.m., and 7 p.m. and 9 p.m. And we send it randomly within those intervals so that we're not necessarily capturing the same point in time every day, right? The goal is to actually get dynamic, differentiating, heterogeneous data. So we randomize within those time intervals. The particular EMA questionnaire, which I'll show you in just a second, has 16 items that are always administered, and then 7 items that come up with branching logic if they answer a particular question in a certain way. In this study, we pay participants $1 per survey, and then we have a compliance enhancement. So if they complete 70% or more of the surveys each week, they get a $5 bonus that week. So they have the opportunity to get up to $20 as a bonus. And we monitor their compliance, and if they haven't completed any EMA surveys in 2 days, we reach out to them to troubleshoot. So that's the general study structure. I want to note that any of the data that I'm showing today, it is real data from the study, but I've transformed the participant ideas and the times that surveys were completed so that I'm not actually showing real data that I don't have permission to share. But I wanted to retain what a real EMA study looked like. So in terms of, who's in it and their answers on items and the time it takes them to fill out a survey, all of those things are real. So I'm going to quickly show you what our EMA survey is for this study, not only so you get a feeling of how long it might take somebody to go through it, but also the types of items that we're asking about. So this will take about 2 minutes. So sit tight while you watch this EMA survey. All right, so that was an example of me filling out the survey, which lasted about 1 minute and 40 seconds. So keep that in mind as we go about to start looking at this data and how participants are responding to this questionnaire. And I will note that was going through it where it made all of the branching logic came out. So the two opportunities for branching logic was if you endorsed anything over a 1 on doing something risky or that had difficulty controlling impulses, it brought up that list of possible impulsive behaviors. And then also, if you've eaten since the last survey, it brought out those questions about urgency in eating. So now let's move into our pre-processing and quality assurance. So theoretically, let's say, we're finished with the study. We've got our data. Now what? Now what do we do to make sure it's clean before we go into analyzing it? Um, this study was not complete. I took a random sample of about 50 people from the study to include in the talk today. The full study is 120 people. So step one, and this is going to be true of any EMA study, no matter what software you use. So I used My Data Helps for this study, but most other EMA apps that you might use or that have IA approval at University of Michigan are going to give you this basic set of variables that I'm suggesting you should compile into one file. And that is your participant ID, the start date and time of the survey, the end date and time of the survey, the device type, so is it an iOS or an Android, the survey name, and the participants' answers. So when you get EMA data from these different software companies, sometimes these variables are split across multiple documents. So you're going to have to do some merging and compiling to get a file that has all of these together. I'm not going to go into those types of pre-processing steps here because it's specific to each other type of app. So from here on out, I've made the assumption that each of you now have a data that has these 6 variables. And the types of things that I've removed from it, because I either don't need it, are other linking variables that I had to use to compile this file, redundant variables. Sometimes you get a start date and the start date and time. And also, if you administer any practice surveys, those might export with your full surveys, and you'll want to make sure to remove those before you do data analysis and cleaning. So a pretty simple file, 6 variables, but this might be 20 or 30,000 rows if you have 120 participants and, 100 surveys. So it ends up being a big data file in the long sense. So this is what it might look like. I do all of my pre-processing and analysis in R, so that's what things are going to look like today, and that's the syntax that I'm going to provide. So this is my data file after I've made it into this basic format. So I've got my participant identifier, start and end time, start day, which I do need, survey name, device platform, and I included one item to show you their answers, but in reality, I have all 23 items of my EMA survey. So our next step is to create a set of relevant variables that we need for pre-processing and for understanding our data. So the first is day and study, right? We have this time variable that has the date and the time they did it, but we don't know what a person's first day in the study is and what their 28th day in the study is. So we create a variable called day and study that is going to, for each participant, give us an output of day 1 through 28 for each of the surveys they complete. So we know which survey, which day. And I'm going to show you what that looks like after this slide. I also create a variable called weekend and weekday. This is because a lot of times in psychological EMA research, we like to know what's different between weekdays and weekends when people might have different responsibilities or be in school on weekdays versus weekends. And survey number. So this is literally just assigning a sequence down the rows to know what survey number is this. So it'll just go from 1 to 112 if they've completed all of them, for example. And so now my data file has these 3 new variables. We've got our day and study, our survey number, and our day type, right? So those have just been added before other variables that we carried in. So now we know if, without having to calculate in our heads with these dates, where are they at this in the study when we're looking at this survey? And again, for this study, we'll have 28 days, and we should have 4 surveys per day. So the next step, which is a really important one that I think most people miss, and this is where we're going to spend most of the time, right? When we're doing any type of research, theoretically, we should have some QA/QC process to identify data that is incomplete or data that is suspicious and doesn't seem real. When we administer surveys on REDCap or we administer surveys on anything, sometimes we put in attention check items to make sure people aren't just going through and tapping through and that we can actually trust the data that we're collecting. This is actually particularly important in EMA where you do get a good amount of random responding. People are fed up with the surveys and they're just hitting 1111111 to get through the survey. They want to get their $1 for filling out the survey, but they don't want to spend their time thinking about, whether they feel nervous or anxious right now, or since the last survey, whether they've tried to regulate their emotion. They're just randomly tapping, right? We have ways to try to see when they do that and clean the data. In any given study that I have done, about 10% of your data might get flagged for being kind of careless or suspect data. So that has substantial implications. So this is a really important step before you start to go and do analysis. Now, we can't possibly catch every possible way somebody's data isn't trustworthy, but some of the main ones that come up that we can suss out are people completing the survey over too long of a period, or completing the survey in too little time, and also randomly tapping through answers or tapping the same answers throughout. So those are the three we're going to focus on today, and I'll discuss a few others that sometimes researchers will look into, but aren't as kind of standard or easy to go through. So the first variable that we're going to create to flag is called time to completion, or TTC. I've added these acronyms because once you do get the code, they're going to correspond to what's in the code. So time to completion is how long did it take somebody to complete the survey, right? So it's essentially figuring out the difference between their start time and their end time.
Sarah, there's a question in the chat. Do you mind if I interrupt and just
Sure.
ask the questions? Okay. What if somebody has ADHD and that's why they're answering too quickly or too slowly?
Yeah, that's a great question. So there are certain participant characteristics that might make you expect that somebody's going to complete the survey in a different way. So when I talk to you about my low flag for time to completion, I'm going to talk a little bit more about how we might think about that, right? There is going through it fast, and there's going through it in a way that even if somebody had ADHD, they couldn't possibly read the question and answer in that amount of time. So that's really what we're trying to get at. And we allow for a wide distribution in how long it's taking people to fill it out. So I think I'll be able to answer your question, Gabe, as I go through this. But if you have a follow-up question, feel free to ask it. And thank you for monitoring the chat, Victoria. So one simple way would be to visually inspect the histogram of all the time differences and see if there's a natural cutoff. So let's try that with this data I have. All right, so this is the histogram. It's not very meaningful to us or usable to us because it's a huge spread. It goes from essentially just above 0 to 46,000, which is many hours, right? So we know we've got some weird data happening that is likely not data that we can trust. But we also know that the peak is over here by 0, but we can't really see what that distribution looks like this scaled out because we have so many or such a wide range. So visually inspecting this, I learned that there's a huge range, and my flag goes up saying, I want to look at some of these really extreme outliers, these high scores, what's going on here. So what I do is I look at my data again. So I have this new time diff variable, which is the time difference between the start date and the end date. And I might think to myself, maybe my code is wrong and calculating this wrong. Or there's something going on that, some people's surveys are staying open for a very long time. So let's look at a few examples. Our person with the longest time diff, which is 45,501 seconds, and we look at what happened. They started the survey essentially at 12:52 a.m., so just after, or a little bit after midnight, and their survey remained open until 1:31 p.m., right? And this is actually the survey from the night before. This is the 7 p.m. survey on day 3. So they completed it after that calendar day, and it remained open until 1 the following day. And so we know we're not going to trust that survey response, right? Like that's way too long. It's now, we don't know if they're answering it about 1 p.m. how they're feeling, and we would be assigning it to the night before. Looking at the next one, this person started it at about 4:37 p.m. and they hit submit finally just after midnight the next day, right? So these are values where clearly somebody started the survey, left it open, never submitted it. And then we don't have confidence whether their answers reflect when they started it and they just didn't hit submit, or whether they were filling it out throughout that time. So right now my flag is going off. Obviously, these extreme, outliers, I wouldn't want to include that data. Now, I will make a note here that this might not be possible for some of your data. So certain EMA apps do have the ability to say, like, if they don't complete it in one sitting, or if they don't complete it over this amount of time, the data doesn't actually get counted. My data helps in how these are set up is that if they start it, they can go back into it, and it can be submitted later. So this is an artifact of the EMA software kind of allowing for this, but certain EMA apps won't. So this might not be as much of a problem in some people's data, but in ours, it's one that we need to pay attention to. So, okay, we know these values are concerning for our data. How are we going to get rid of them in a systematic way where we're not arbitrarily just saying like, oh, this one looks bad, this one looks okay, this one looks bad, this one looks okay. Oops. So one thing we can think about is, well, how long do we think theoretically the survey should take? If your goal is to capture something in the moment and you want all those items to really be assessing the same moment, then you might make the argument, I don't want to include any data that, they're in the survey longer than 10 minutes. That is, again, a very arbitrary decision, so I don't usually go with that. The third is thinking about a standard deviation cutoff, looking at the data itself and telling me what are the outliers. And that's the method that I typically go with because it feels the least arbitrary to me. So how do I do that? The first thing I do is I look at 2 standard deviations above the mean time to completion. And so in this data, the mean time to completion is 150 seconds. That jives with the about the time that it took us to go through it together. Our standard deviation is wide. It's 1,006 seconds. So Gabriel, this is where, we've got a large range in how people are responding. And there might be some people who are taking 2 minutes per question because they're really thoughtfully thinking about how they want to answer it. And then there's others that are thinking really quickly and going through it, and we want to accept that. So we've got our standard deviation of 1,006. So that makes anything over 2,162 above 2 standard deviations. So that's what I'm thinking about for my flag. Now, what do you do for low time? Because obviously 2 standard deviations below the mean would be a minus number because our mean is 150. This is where the kind of standard I've used is that it seems it's likely implausible that somebody could read the question and meaningfully respond in less than 1 second per question. So this is pretty generous. And so if you say the maximum amount of items somebody can get in a survey is 23, and I'm gonna say it's acceptable that they go through each of those for 1 second, then my low time would be 23 seconds. That would be the fastest that I think somebody could get through this survey. Anything under that, I'm saying they're not even reading, they're just tapping really quickly. This 1 second rule is used in many people's EMA research in terms of psychological EMA questionnaires. So this isn't a number I've just made up. I'm happy to share some references. But that's kind of the lowest amount, recognizing that there's going to be some people in there that fill it out in 1 second that are probably not thinking very hard about their answers. But we don't want to get rid of data that's real.
Sarah, there's another question in the chat. It was recommended to use the same question order to reduce participant burden, but this can also be a limitation as participants might not think about the questions as much once they've learned the order. Is there a way to balance participant burden versus data quality, or do you have any thoughts on a best practice?
Yeah, that's a fantastic question. And two thoughts come to mind immediately. First is yes, you see time to completion typically get lower as people get further along in the study if you have a fixed order, right? They do know that order. They don't have to read as much to be able to answer. So you anticipate some reduction in time. I don't necessarily view that as a problem because, again, my threshold is set low enough that even if they're going through it a lot faster, even just hitting something for one, like hitting your score and hitting submit for that to take less than a second would be very surprising. In terms of randomizing questions on a questionnaire like this, that would definitely increase time to completion, right? Right now I do have it very much grouped, right? I'm assessing your emotions, and then I'm assessing kind of your perceptions of your emotions. Then I'm assessing impulsivity. Then I'm assessing eating, and then I'm assessing these contextual variables. So I'm keeping your mind kind of thinking about the same thing as you fill out questions. If that gets randomized, then I'm going to be jumping back and forth, and that's going to make me kind of re-register at each question. So I do not typically randomize question order in EMA surveys. So I think, it sounds like that's what you were recommended as well. If you're really concerned about burden, amount of time it's taking people to complete a survey, there are also some randomization methods that people use where they're not getting all 23 items every time. So Kevin King is a researcher at University of Washington who's done a lot of this in his EMA research. So that's where I would point you to if you want to learn about these methods. But let's say he has 6 EMA items to measure one construct of interest. He randomizes it so that each survey they might get 2, and then next time it's 2, and then next time it's 2. So they're never getting the full 6, but they're getting full coverage over those 6. And he's done enough psychometric work on those items to know that ultimately whatever index he creates with those different scores is going to be, valid. So that's one way you can reduce item numbers, not make the survey a lot longer, but have things be less predictable. Good question. All right, so we've got our cutoffs. So 2,162 for the TTC flag on high end and 23 seconds for the TTC flag on the low end. Pulling up our histograms again on the left, this red line is now where we're cutting it off in the full span of view. If we change the range on the y-axis and kind of zoom in on now what we're including, we can now see, this kind of nice normal distribution way over here towards 0 and we know kind of the peak here is around 150 seconds. So I'm okay with how this is looking. So I'm going to go with that. I'm going to make the assumption that, these few throughout kind of 1,000 to 2,000 are people who are taking more time to get the survey done. So I have some R code throughout, some snapshots. This is just to give you a sense of what these functions are going to look like. Ultimately, when they get posted, they'll look a little different to make it more accessible to anybody's data, not just mine. But I did not have enough time to do that to put that in the talk today. So that'll be forthcoming. But we've got our flag where we're creating this variable, TTC flag high and TTC flag low, where we're going to have a new variable with a 1 or a 0. Is it getting flagged or not? And that's for each survey. Okay, before I move on to the next slide, any other questions about time to completion? Because I'm going to move on to the next category, which is variance in responding. No. All right, so I'm going to move on. So the other scenario we talked about that would be concerning for data is if people were just randomly going through and tapping through really quickly. One thing we know that when they do that is they're typically tapping on the same score every time. Occasionally, you will see people who really systematically just alternate like 1 4, 1 4, 1 4, 1 4, 1 4. So you can also look into patterns, but today I'm just going to talk about the scenarios where you've got the same answer for every item, right? So what we do is we calculate the standard deviation across any of the continuous or Likert responses. You can't do this with categorical or, free response ones. There are ways to do that, but let's say we're going to take all the items in the survey where they have the same scale and could be responding the same way. And we calculate the standard deviation of their responding within each survey. If they have a standard deviation of 0 for that survey, that means they answered the same question with the same answer every single time. Now, what do we think the probability of that is in a survey like this? Pretty low, right? Because that means they're saying they have no emotions, no behaviors, and nothing varied, like nothing is variable. So we go through and we flag, we have a variable that we create that's SD flag, oops, where it's a 1 if it's a 0 and a 0 if there is variance. So that's a little bit counterintuitive, but just remember 1s are always flags. So then I have some code to like visualize each of these across participants. So this is our time difference per participant now that we've cleaned it up. And if you look in general, participants, are around 0. We have a couple people like this fake 90,764. They have more range in the time it takes them to complete their surveys. But in general, people are looking pretty similar. So I'm happy with that. These are the frequency of the SD flags by participant. So here, the yellow columns means it's not a flag. They have variance in their responding. Blue columns are ones where the survey has no variability. So let's look at 52399, right? This person, you'll see later, 85% of their responses, they have 0 variability in their responding. So this person's likely going through the majority of the study and just clicking the same thing every time. It's a 1 every time in every survey, right? That should send a flag up like that person's data is probably not very trustworthy. It's understandable that some people might have some, but like people like this and this and this, it's less concerning as a picture like this. But where they're almost equal to, so this person, I get a little bit concerned about that. It just means that if you think about this is about 80 surveys that they have where there's 0 variability, which would be very surprising. So this is just kind of a per participant view, and these figures will be, available for you to pull your own data to take a visual look at, okay, what's going on. But let's get some more concrete flags now and look at, okay, how do I identify who I might want to drop or what surveys I might want to drop if I'm concerned about their quality. So the next thing that I do is create a new data frame that's basically just going to have the participant identifier, how many flags they have for each of our flags, and the percentage of the total amount of surveys that they've completed where they have a flag. So this top one, I've arranged where it's descending. So the percent standard deviation flag, I'm trying to identify people who have a large percentage of their data where they have no variability. So that person that we visually saw that was concerning, 85% of their data has no variability. This next person is about 30%, so on and so forth. Small amounts, not so concerned about. Large amounts, much more concerned about. So we want to kind of look at our SD flags. Next, we want to look at the low flag. So this is people who have surveys that they're completing it in less than 23 seconds. So this person has 10 surveys, so much small, or 10% of their data, much smaller than the SD flags. And we have a few hits, but not many. People aren't going through it too quickly. That's not excluding a lot of people. And then our high flags, the highest amount is 5% of the data. So that's reassuring. We don't have, massive amounts of data that we might lose if we use this flag. Now, putting it all together, we might want to ask who has multiple flags? Like, who are we really concerned about? So there's some code in here to basically say, show me the IDs when they have 2 flags or more. So these IDs here are now the people who have flags on at least 2 of the categories. You'll notice that our 85% low standard deviation also has a lot of flags for filling it out too quickly, right? So again, that's telling this story that that person is going through it really quickly and randomly tapping their response. So we have to ask ourselves at this point, do we want to remove individual surveys that are flagged and set to missing? Like, do we not trust that data enough that we don't want it in our data? Or are there whole participants based on these rates that we're concerned about including their data, even if they have some data retained that doesn't have flags? And that's a hard question. And depending on who you talk to, you're going to get a different answer. And it might matter. It might depend also on your study. If I have 2,000 people in my study, I might be a lot less concerned about 3% of the data having a flag than if that's 80 or 90 people, right? So I can't really give you a steadfast rule for this one because the answer is it depends. I can tell you what I'd choose for this study with this data of what we've seen so far, which again, the goal of the data in total is 120 people. It's over 28 days. I can tell you right now that I'm probably going to drop 52399 from the EMA analyses. 85% of the data I can't trust. And, the other 15%, if I look at it, I don't know if it's back and forth or maybe, you could look into it. You could see, oh, the first couple days, were they really with it? And then they just started randomly pressing through the rest. But those numbers really concern me. So this is probably the only person I would fully drop from these flags. And in terms of what I do with individual surveys, is that I likely would set these flagged data as missing. So I would replace their values as missing and not analyze that data. Again, if 30% of the data for this person is concerning, I don't want to use those values, but they have 70% of the rest of their data that I'm saying I trust. So that's the decision I would make here. It might not be a perfect decision, and it might look different depending on the study. We have a comment from Rima. Oh, just saying, appreciate it. Thank you. All right, so moving forward, right now we're going to say we're dropping 52399, and we're setting surveys that have flags as missing. And in the grand scheme of thing, because of the amount of within-person repeated observations I have per people, I can take that chance. So what other things might I want to consider if I'm designing an EMA study or analyzing EMA data to think about the quality of my data? One thing that other researchers will do is put attention check items into their EMA surveys. So this means, it could be random, it could be in every survey, but once in a while they'll get a question that comes up that's like, 1 + 4 = 5. Or my lab that I was in grad school used pretty hard attention check items. So it was things like it takes longer to fly from New York to San Francisco than to drive. So like things that you really have to think through. And if you fail attention check items, then that survey just gets set as missing. So that's a way of doing it on the front end. I tend to not do that because it makes the surveys longer. And in a long study that's like 28 days, your participants are catching on and they might then feel like, oh, you don't trust me. So I've gotten that feedback before where I've used attention check items in EMA. And so I decide to handle it on the back end than the front end, but some people feel differently. Another metric that you'll see people flag on is not time to completion, but time per item. The reason why I didn't go through this today is because not all EMA software will give you time per item. My Data Helps actually does. So if you have My Data Helps data, we could calculate this. It's in a separate file where you have start and end time for each item. And there you could say flag if the item is less than 1 second. I think it ends up being a little bit redundant with time to completion, but let's say you were testing out some new EMA items and you want to know which ones are valid. You might do a method like that to see, oh, is there an item that's taking people a lot more time than others? Or conversely, not a lot of time at all. And maybe they're struggling with it, so they're just pressing randomly. So it can be helpful, like kind of diagnostically, if you're designing surveys to look at time per item. But I don't usually exclude data based on time per item, but you can. All right, step 4 is missingness. So this is less now about how are we including data or not, but just giving you guys some code and some ideas about the types of things you might want to look at in terms of missingness. So the first bit of code I have for you guys is just to identify the missingness and calculate compliance. The way I do this is, to find each person's expected surveys, actual surveys, and then you can flag based on whether it's missing or not. So it creates something like this. You've got each participant, all of their days in study and survey name, and it's essentially entering a line where there should be a survey that there wasn't and giving you a 1 for a missing count. And then you can look based on that and calculate, okay, how many did they have missing? How many did they complete compared to what was expected, and get a % complete score over here. Now you'll notice, and some of you might have seen my EMA questionnaire and been like, oh, that feels long. Our compliance in this study is really high. I mean, look at these, 91, 98, 98, 100, 100. Remember, that's 4 a day for 28 days. So if you do a really good job coaching people on EMA and pay them right, you can get really high compliance over long periods of time. So then I like to look for patterns related to missingness. The 4 things I'm going to look at here for you guys is time of day. So remember, those surveys are kind of chunked across the time of day. Weekend versus weekday, device type, and diagnosis. So remember, we have those 3 groups: healthy controls, subclinical, and bipolar, where you might anticipate seeing differences in missingness. So I'm going to show you these visually. So for these figures, the blue columns are complete number of completed surveys, and the yellow is the amount of missing. And this is time of day. So this is our morning survey, early afternoon, late afternoon, and evening. And what you really want to compare here is the yellow bars. I have no statistical tests on this because I manipulated some of the data, so it feels meaningless. But generally, visually looking, we see maybe slightly less missingness in the evening and the most missingness in the morning. This kind of jives with the population we're studying, where we know they tend to have a more delayed sleep phase. So maybe that 10 a.m. survey, people are missing because they might still be asleep. Next, we're going to look at day type, weekday versus weekend. And we see right off the bat, we have a lot less missingness on weekends. Again, maybe, so depending on your population, this could look very different. In college student samples, we see higher rates of missingness on weekends generally. And that's because people are partying or sleeping in or at the football game. But in our kind of working, more community populations, we tend to see less missingness on weekends because we aren't in meetings, we aren't, um, necessarily as occupied. Device type, missingness is dead even between Android and iOS. So that's a good test of whether your EMA software works better on one versus the other. And lastly, by diagnosis. So here we have bipolar disorder, here we have healthy controls, and here we have the subclinical. So our highest amount of missingness is in our clinical group, and our lowest amount is in subclinical. But note, these aren't percentages. So our subclinical group in terms of recruitment is lagging behind. So this could just be because there's a lot less people in that group, because I would think kind of like a step down. This is just showing you percent compliance at this point of this randomly selected 50. So I tend to look at medians more than means. So for our bipolar disorder group, it's 87.5. Our healthy controls, 95.7. And our subclinical group, 79.5. And our bipolar and healthy controls, our range includes 100% in both those groups and 96. So overall, our median is 92.9 with a mean of 84. So in EMA speak, those are very good compliances, particularly for a 28-day study. We're happy with those. Lastly, I added some code to start looking at item characteristics, which is the last really important step before analyzing. You might make an assumption that all these EMA items are going to be normally distributed. They're not, particularly when you're using psychological variables. So I put in some code to do some histograms of different items that you might have in your EMA survey. I randomly selected 6 from ours. So we have nervous, anxious, sad, blue, irritable, angry. So our negative affect items tend to be zero inflated, essentially, which in a clinical population, that makes me happy to see. I'm not seeing large amounts of negative affect in daily life. That's a good thing. Our positive affect items are more normally distributed, but do have, an increase at 0. Our energy level, this scale goes from -5 to +5, so it's perfectly normally distributed. Oops. Okay, sorry. Here's situation stressful. Again, more zero inflated, emotions out of control, more zero inflated, impulsivity, really zero inflated. So this is really important to look at first before you start building your models, because if, that has implications for what model you run. You might have to run a Poisson model if you have a, zero inflated variable versus just doing a multi-level or mixed effects model if you have normally distributed. So it's good to look at all of this before you even start analysis. And if you're somebody who pre-registers EMA studies, which I always recommend, you can build in essentially to your pre-registration, well, I'm going to look at my data. If it's zero inflated, I'm going to do this type of model. If it's normally distributed, I'm going to do this type of model. So you can just plan for it in advance. I also like to look at whether there's differences in items based on time of day, because if there's so, I might include that as a variable in my model. So this is happy, joyful, nervous, anxious, and energy by the different surveys. So 10 a.m., 1 p.m., 4 p.m., 7 p.m. So for happy, joyful, it's a little bit hard to see, it's small, but you see no differences based on time of day. Nervous, anxious, maybe I doubt it's significant. Again, very similar across them. And then energy is slightly lower in the last one, which you would anticipate towards the end of the day. So just again, a sanity check on your items before you're throwing them into models. So in summary, kind of the steps I recommend taking with your EMA data is to build your basic data file. If you want to use this code in the future, you'll build it with those variables that I recommended. And then you'll create your time variables. You'll go through your flags for TTC and standard deviation. You'll identify the surveys or people to be removed and make that decision based on your own study. You'll characterize missingness and examine item properties, and then you'll analyze. And with that, we will end with, I thought it was going to go a lot faster than that, 5 minutes for questions. And